Okay, so we're going to get into coordinate proof here. So the first one is prove a parallelogram using coordinate geometry. There's 4 different methods that you can do to show based on the properties of parallelograms. We're going to stick with the definition. The definition of a parallelogram is to show that both sides, both pairs of opposite sides are parallel. So how would we use this? That means if we want to show 2 sides are parallel, they should have the same slopes. And there should be 2 sets because there's 2. So one set of parallel sides might have something like a slope of 2 and a slope of 2, and the other ones might have a slope of like -1/3 and a slope of -1/3. There should be 2 equal sets since we're having 2 parallel sides, 2 sets of parallel sides. So let's look at this. There's other ways to do it based on properties. We're going to stick to the definition in the video. So given the vertices, so let's graph it first. 1, 1 is J. 2, -6 is U. 3, 3 is M. And 2, 10 is P. So when I connect, let me move that J out of the way there. When I connect these points, we want to show that this thing is a parallelogram. So let's first try to show that JP is parallel to MU. So let's do the slope. I'll write out the slope. Slope of line segment JP is, well, using the points J and P, I'll just write them up here so I have them. J is 1, 1. P is 2, 10. I go Y minus Y over X minus X. I get 9 over 1. I do want to reduce my slopes, so I get a slope of 9 for JP. Now we're going to check out the slope. That's not how you spell slope. Of MU. So again, M is 3, 3, and U is 2, -6. So if I do the Y minus the Y, I'm going to get 3 minus a -6. And then X minus X, I'm going to get 3 minus a 2. So a 3 minus a -6 becomes a 3 plus 6. So I get 9 over 1, which is 9. That shows that those are indeed parallel. That makes it a trapezoid. One set of parallel sides, but we're trying to prove parallelograms. So now let's look at the other sides here. Let's show that now PM is parallel to JU. So if we're going to start with PM, M is 3, 3, P is 2, 10. So I want to do the slope of PM. So I'm going to go Y minus Y over X minus X. I get 7 over -1. We're going to call that a -7. Now we're going to do the slope of JU. So we know that J was 1, 1, and U was 2, -6. So the slope, I keep spelling slope without the L. That's awesome. The slope of JU is Y minus Y, 1 minus -6 over 1 minus 2. 1 minus a negative becomes a plus 6. 7 over -1, that is -7. So PM and JU are parallel. You just proved that that's a parallelogram, so you do want to make a statement. We have to explain, because both pairs of opposite, okay, sides are parallel, we have a parallelogram. I know I forgot the A, but we're going for it. So we proved that it's a parallelogram. You should say maybe a little bit more here. You know, honestly, I'll write it in purple because I'm going back. So JP and MU are parallel because, you want to tell me why, their slopes are equal. You need to say that. I forgot to mention that. So P and M and JU are parallel because their slopes are equal. If you want full credit on the take-home assessment, you need to be writing these statements. You can't just show some work, get these numbers, and go, yeah, it's a parallelogram. We need this explanation. We got to have this explanation to get full credit. We got to have the final conclusion to get full credit. You're sort of restating the definition here of a parallelogram. You're saying because the definition holds, right? Two sets of parallel sides, opposite sides parallel, however you want to say that, but you gotta make those statements. So that's the coordinate proof for a parallelogram.